Okay, so we're going to start out looking at ellipses. Tonight's homework, tomorrow's homework, those are both going to be in this packet. Okay, you do not need your book until Wednesday. Okay, Wednesday's the only day we're going to use the book this week. So, each time we look at a conic section, okay, we start out with what the definition of it is. Then I'll show you the definition kind of as a picture, which usually helps it make more sense. So, with an ellipse, let's start with even more basic. We started with a circle. Okay? So, if you wanted to define a circle, it's a very simple definition. It's a collection of points that are all equidistant from the center point. That's it. That's a circle. Okay. Simple shape, simple definition. When we got into a parabola, it was a little more complicated. Okay, parabola was a collection of points that were equidistant from two things. One thing was called the focus, the other thing was called the directrix. So if you measured the distance from any point on a parabola to the focus, and that same point to the directrix, those two distances always came out the same. With an ellipse, a little different. It's not going to be that two distances are the same. It's going to be that if you add up two distances, it's the same. So if you take any point that's on the circumference of the parabola, or perimeter, they don't call it a circumference, the perimeter, and you measure the distance from that point to a special point, and from that point to another special point, which I'll tell you what they're called in a minute, it will always add up to the same number. What that number is, well, it's different for different size ellipses. But for a given ellipse, that number will always be a constant. I'm going to show you in my ellipse. So, first you have two special points that don't move, two fixed points. In that picture, those are points B and C. They don't move. E is a point on the edge of the ellipse. Okay. I'm going to drag point E to different spots. And what I'm going to do as I drag it, I'm going to keep track of that distance from B to E and that distance from C to E. So you're going to see these two numbers change as I drag point E. But what's not going to change is this number. When you add up those two numbers on the left, it's always going to equal 17.3 for this particular ellipse. So let's try it. Just move that over there. And now let's add those up. 3.8 and 13.5. If you add those together, it's 17.3. Now, it might come out a little off because I'm rounding to two decimal places. But most of the time, whoops, it comes out the same. So just drag that point. And no matter where I drag it, those two distances always add up to 17.3. Any questions on that? That's the idea of an ellipse. The sum of those two distances always comes out the same. What it comes out to, in this case 17.3, not important. Okay? Just the idea that they always come out the same. So these two fixed points have names, B and C. Can you remember the name of the thing that a parabola wrapped around? It was a point inside the parabola?
Focus.
The focus, yes. That's what points B and C are called, except it's plural, the foci.
That's a word.
What's that?
That's a word.
It is.
But
You don't say. The foci. I say foci, some people say foci. I think it's pronounced foci. I don't really care how it's pronounced. All right, so the two fixed points are the foci. Okay, I'm going to show you a diagram. I'm not going to explain all the terms yet. I'm going to kind of explain them as we go. So the only thing I've explained to you so far is this. That if you take the distance from any point to the first focus and measure the distance from that point to the second focus, add up those two dotted line distances, they will always come out to a constant, no matter where you drag point P. Okay. And if you actually wanted to draw an ellipse, if you had like a piece of wood and you put in 2 screws at F1 and F2, and then you took a loop of string, right, and put it around the 2 screws. If you keep the string pulled tight, okay, put a pencil in the string and keep it pulled tight the whole time, that's how you draw an ellipse. And if you take the 2 screws and put them closer together, the ellipse starts to get more circular. If you take the 2 foci or the 2 screws and put them further apart, make sure you keep the string pulled tight the whole time around the 2 screws, your ellipse gets longer. But you could do the same thing on like a bulletin board. Just put in 2 push pins at 2 points, take a loop of string, keep it pulled tight, and you'll get an ellipse. The reason it's not a circle is because you got 2 of them. If you just put in 1 and then put a loop of string on that 1 pin and keep it tight, you'd get a circle. All right. So the line that contains the foci, that's called the major axis. So line that contains the foci, major axis. So kind of in the beginning, there's a lot of different terms we have to go through. Well, once we go through them, there's no vocabulary after this first page. All right, so if you find the midpoint of, let me try to draw this in a different color. Find the midpoint of that green segment. That's called the center. It's always halfway between the 2 foci. So the center is the midpoint of that segment that I just drew in green. Now, if you draw a line, I think I already had it on the board, you might have seen it. The other way, up and down, you get your other axis. Did anybody see what I had up there? One of the axes was called the major axis. And did anyone see what the other one was called? The minor axis, yep. So the minor axis and major axis are always perpendicular, just like x and y axis. So if you draw a line through the center, perpendicular to the major axis, that's called your minor axis. Okay? So tomorrow, we're going to see all these words kind of come up again. Different axes. Just sometimes the names change a little. Tomorrow's lesson still has foci, it still has center, and it still has 2 axes, but we don't call them major and minor tomorrow. But today they're called major and minor. All right. When you draw your major axis, it hits the ellipse in 2 spots. Here. And there. Where the major axis hits the ellipse, those are called your vertices. And I've labeled them V1, V2. Okay, so where the major axis crosses the ellipse, those are your vertices. Where the minor axis crosses the ellipse, there's no special name for that. So there's no special name for this point or that point. It's helpful to know those 2 points, because if you know the 4 dots in green that I have up there, it gives you a pretty good way to sketch it. Okay, 4 points kind of gives you the length of the ellipse and the width. So any questions, or anyone need me to scroll up so you can copy down any of the terms? More than those?
No, like the picture.
The picture?
Yeah.
So F1 and F2 are focus 1, focus 2. V1, V2, vertex 1, vertex 2. And P is just a random point anywhere on the perimeter of the ellipse. Okay, so things we're going to do with these kind of problems, really two main things. I'll give you an equation, and I might say, all right, looking at the equation, tell me about the ellipse. And there's really 4 or so important things you have to tell me. Or we'll do it the reverse. I'll tell you the important stuff about the ellipse, and you'll give me what the equation would be. We'll do a little bit of sketching, but any sketching you have to do on the test will be multiple choice. So I'm not going to spend a lot of time on detailed, perfect sketches. All right, when we did parabolas, how many different ways can a parabola open? Or how many different ways can it face? Yeah?
Was it 4?
It was 4, right? It could open up, down, left, or right. Well, with an ellipse, there's really only 2. Either your ellipse has the long way horizontal, or the long way is vertical. That's it. So there's only 2 equations we're going to look at. We're going to start out by looking at the formula when the ellipse has its center at the origin. Okay, that's the easiest one to start with. So the center's at the origin. And the foci are at negative c comma 0 and positive c comma 0. Right, so that letter C, I haven't really explained what that is yet. That C means something, and there's a way to find it. There's going to be 3 letters involved for now. A, B, and C. C has something to do with the foci. A is going to have something to do with the vertices. Okay, and both A and C are going to measure distance. And this is the particular case where the major axis is going to be horizontal. So remember I said there's 2. Major axis can be vertical, or the major axis can be horizontal. This one is horizontal. And that's your equation. Little different from a parabola. Okay, one thing that was different in a parabola is that only one letter was squared. You know, if you want to sketch a parabola, either the x is squared or the y is squared, not both. If you square both, it turns into a different shape. This is one of the shapes it can turn into if both letters are squared, an ellipse. So the equation is x squared over a squared plus y squared over b squared equals 1. So I told you there's going to be 3 letters involved, A, B, and C. Well, still not telling you exactly how to get A and B, but what I am going to tell you is A is always bigger than B. And B is greater than 0. So that means A and B are always positive, and A is always the bigger one. So, if you're ever given 2 numbers and you're not sure which one is which, the bigger one is A. Okay, always. So there's A, there's B. Now, the problem is the foci use this letter C. Well, I didn't write anything about C until I put up that formula. So that's a formula that gives us a connection between A, B, and C. That's important because if we only know 2 out of the 3 letters, that's okay. As long as I give you 2 out of 3, you can use this formula and find the 3rd one. Kind of looks like Pythagorean theorem, but it's not. It's just c squared equals a squared minus b squared. And you can put that, if you want to make a reference sheet, you can put that on your, this on your reference sheet. All right, don't worry about that part. I'm not going to do that. Okay. So now, what are A, B, and C? So A is the distance from the center to the vertex. So A is the distance from the center to the vertex. B is the distance from the center to the minor axis. And C is the distance from the center to the foci. If you want to abbreviate the way I did on the left-hand side, I just showed it on the whiteboard, I just made it very short. So A is distance from center to vertex, B, center to minor axis, C, distance from center to foci. So I'm going to scroll back up and I'll show you each one of those in a picture. Or I can just draw it on. So major axis left and right, minor axis up and down. That's my center. Let's put foci, or focus, vertex, vertex. All right, so A, distance from center to vertex. That would be, let's use this color. Center to vertex. Right there. That's A. B, distance from center to minor axis. That's that. Distance from center to minor axis. C, distance from center to foci. So those three things that I just drew, that's what they would be in an actual picture. So any questions on what A, B, or C mean? Now, let's go back up to the equation for a second. If you look at the equation, what number is it equal to? 1. Always has to be equal to 1. What can end up switching places are those two things. Wherever you put A, that's going to tell you which way your major axis goes. A is always the bigger number. So if the bigger number is under X, the major axis is going to go the long way on the X. If we switched A and B, okay, which I'm going to write that formula later, but when we switch A and B, and you put the bigger number under Y, that makes the major axis go in the Y direction. So wherever the bigger number is, that's the direction of the major axis. Bigger number under X goes in the X. Bigger number under Y, it goes in the Y. So just look for A. Okay? Look for where A is. All right, so let's see if we can find an equation of this ellipse. So that's pretty typical. They tell you a few things about it. The center, focus, vertex. Let's see if we can figure out any of these letters. That's always the first thing you have to do, no matter what kind of question it is about a conic section. Always see if you can figure out the letters A, B, and C first. So, do I have enough information to find any of those letters right there? Yeah?
You can find A.
I can find A, the distance between the center and the vertex. Well, my center is at the origin. My vertex is -4, 0. So what would A be? Yeah, A is 4. All right. Do I have enough information to find something else? They got to give me enough information to find two things. But that's one of them. C, yep. Distance from center to focus. What's the distance from the center to the focus? 3. Now, I'm missing B. I need B. If I'm going to write the equation, I have to know B. So what's the formula I can use as long as I have 2 out of 3?
C squared
Yep.
equals A squared minus B squared.
C squared equals A squared minus B squared. Okay, and now we'll fill in what we've got. So C squared, A squared, minus B squared. Alec, what would I do to solve that? Just one step.
You subtract 16 from both sides.
Yep, we subtract the 16, so that's gone. Subtract 16. It's going to give me negative 7. Anything I can cancel from both sides?
Negative.
Yeah, the negative. You can think of dividing each side by -1. Gets rid of the negative. And now, what would be my last step to get B?
Square root.
Yep, take the square root. So B is the square root of 7. Now, technically, if I'm going to write the equation, I didn't really need B. I needed B squared. But if they want me to graph it, I really need to know B, the distance from the center to the minor axis. So I'll graph this one, just so you can see how to graph it. Okay, but that's the first step. Any questions on how we got that? All right. So now, set up your equation. What did I say earlier? The equation of an ellipse is always equal to what number? 1. Always equal to 1. It's always going to have 2 fractions. What goes between the 2? What is it?
Plus.
Plus. Today it's a plus. Tomorrow it's going to switch to something. But today it's a plus. Now, these 2 things never change.
X squared and Y squared.
It's always x squared and y squared. And when I say they never change, I mean the x is always the first one, the y is always the second one. Okay. Now, the 2 letters that go in the bottom are a squared and b squared. And it makes a difference which one we put where. Right now, you only know this equation, so it has to be this one. A squared must be the first one, b squared must be the second. But the way I figure out which equation it is draw those points. There's your center. Your focus is 3 units right. Just a quick rough sketch. Your vertex, there's 4 units left. How do those points line up? Do they line up horizontal or do they line up vertical? They line up horizontal. So that means they line up in the x direction. So put the bigger number under x. What's the bigger number? A is always greater than B. So you put A under the x, A squared. If I wanted the points to line up vertical, I would put the bigger number under what? Right? So A squared, B squared. 16, 7. And there's the equation of your ellipse. And now let's graph it. All right. So graphing it, it's pretty easy. Okay. Where was the center for this one?
0.
0, 0. Yeah. So I don't need to put a dot there, but if I want, I could mark the center. It's not really part of the ellipse, it's going to be inside the ellipse. Now, how far was it from the vertex to the center? How many units? 4 units. Now, how many vertices does an ellipse have? 2. They didn't really tell me both. Technically, they could have just done this. And they could have done this. but they didn't. Right? By them telling me one, I automatically know the other one because it's symmetrical. Okay, same on each side. So we have a vertex at 4, 0, negative 4, 0. What the two vertices tell me is how long my ellipse is going to be. Now I need to know how wide it is. Which one of these numbers, A, B, C, tells me the width, or basically the distance from the center to the minor axis?
B.
B. So it's square root of 7. That's not a very nice number. We'll say about a little over 2.5. So that means my minor axis, 2.5 units up, 2.5 units down. And there's my ellipse. Okay. Just try to sketch it the best you can. So maybe, it's okay. But there's my ellipse. Any questions on that? Now, if you wanted to sketch this on the calculator, you can. But what letter always has to be by itself to do that?
Y.
Y would have to be by itself. So this part, I just want you to watch. That's why I didn't take the calculators out. There's an imaginary 1 in front of that x squared. So you can think of this as like 1/16 x squared. That's what it basically is. How would you move that to the other side? I mean, it's just like having like this.
Subtract it.
However you would move 3x squared to the other side here, you do the same thing here. Yeah,
Subtract it.
yeah, just subtract it. So just bring it to the other side. So you get y squared over 7 equals 1 minus 1/16 x squared. You can write 1/16 x squared like this. You can write it like that. It doesn't matter. How about this 7? How would I put that on the other side?
Multiplying by 7.
Yep, multiply each side by 7. That's going to become this. I just multiplied each thing by 7. 1 times 7, 1/16 times 7. I don't know what 7/16 is. I don't really care. And the last thing, how would I get rid of that square root? I mean, how would I get rid of squaring?
Take the square root.
Yeah, take the square root. All right. And when you take a square root, how many answers are there?
2.
2. Positive and negative. So to get y by itself, it looks pretty messy. Okay. We usually like to leave it just like I have in purple. But if you really wanted to graph it on the calculator, that's what you'd have to do. Okay. Let's type it in and see what it looks like. So square root of 7 minus, and yes, I would put it in parentheses like that. 7/16 x squared. Now, that's just going to be the top half. Okay? Because the calculator can't really sketch an ellipse because it fails the vertical line test. But you can kind of cheat and do the top half and the bottom half separate, like I'm doing right now. And it doesn't even really connect. I mean, it should connect, but I can't, with this calculator, I can't really do it any better than that. Right, so let's check it compared to our sketch. So it goes 4 units left and right. 1, 2, 3, 4. Looks good. And it goes about I said a little over 2.5 units up and 2.5 units down. That's the distance from the center to the minor axis. So that's what it should look like, but it should connect. Okay. That's the only time I'm going to use the calculator today. So any questions on the sketch by hand or equation? All right. Let's try this one. Okay, this is the reverse of what you just did. So now they're giving you the equation. They want you to describe the ellipse. Okay, tell me all the different things about it. Okay, when they ask you to describe an ellipse, here's the 4 things that they want you to find, and I would find them in this order. Center, which way the major axis goes. Your choices would be horizontal or vertical. What else? The vertices. And the foci. Those are the 4 things. You're not going to have to memorize that those are the 4 things when they say discuss. I will ask you for those 4 things. Okay. So, the center so far has always been where?
0, 0.
It's always been 0, 0. You'll know when it's not 0, 0. Trust me, it's very obvious. So the center is not 0, 0. Is at 0, 0. Okay. Major axis. Which way does the major axis go here? Horizontal or vertical?
Horizontal,
Yes, how come?
because the number under x is greater.
Yes, because the bigger number is under x. Now, that's pretty much all you can do without finding a, b, and c. You can do those 2 things. But now we really need a, b, and c. So, let's start with a. What's a here? Careful. Yep. 5. Any question on why it's 5? Okay. How about b? 3. Now, if they didn't ask for the foci, I wouldn't care about c. But they want to know where the foci are, so I have to find c. Okay. If I know a and b, how do I get c?
Square the 2 and subtracting.
Yeah. C squared equals a squared minus b squared. So c is going to actually comes out nice here. What does c come out to? 4. 4. Okay. So now we can get the last 2 things, the vertices and the foci. Which number here, a, b, or c, tells me something about the vertices? A. Tells me how far away the vertices are from the center. I know they're 5 units away. If that's all you knew, that's not enough. Okay? Could be 5 units left and right, or it could be 5 units above and below. I know that it's left and right, okay? Because the major axis is horizontal. So, what would be the coordinate that is 5 units to the right of the center? 5, 0? How about 5 units left? Yeah, so I'm just going to write it like this. Okay, so now what letter tells me something about the foci?
C.
C. Tells me the foci are 4 units away. 4 units above and below, or 4 units left and right? Which way?
Left and right.
Horizontal. Left and right. See, that's why you need to know the major axis. So I'm at the origin. What's 4 units to the right of the origin?
4, 0.
4, 0? 4 units left.
Negative 4, 0.
Negative 4, 0. And that's how you find all of those things. Okay. Any questions on how I found those? Okay, let's look at the other equation of an ellipse, where now it's going to be, well, everything is going to be up and down. Okay, before it was horizontal, now it's going to be vertical. Center still at the origin. But now the foci are C units below and C units above. Okay, so notice this time it's the y value that's changing, not the x. C still has the same meaning. It's still the distance from the center to the foci. It's just up and down now. So major axis goes up and down. Major axis is the y-axis. For the vertices, A still has the same meaning. It's just up and down. Okay. A units below, and then A units above. All this stuff on the right is the same. A is still bigger than B. B is bigger than 0. C squared still equals A squared minus B squared. None of that changes. Now, looking at this equation, what's the only thing that changed compared to the equation you had before?
Position of A and B.
Yeah, A and B just switched places. Okay, so yeah, A and B just switched places. That's the only difference. Now the bigger number is under the y, so everything's going to go along the y-axis, up and down. Okay. Other than that, that's the only change. Any questions on that one? Okay, let's try a couple of those. Sometimes maybe I'll give you one where you have the equation, and I'll give you one where you have to find it. Okay, so this is one I'm giving you the equation, but something's wrong here. What's wrong with that equation?
It's not in the right form.
It's not in the right form. To be in the correct format, it should equal what number? It should be equal to 1. So what would I divide everything by to make it equal to 1? Yeah? Divide by 9. So now you don't have any denominator for x squared, so you got to put something there, right? We'll just make it a 1. We're going to have y squared over 9 equals 1. Now you're ready to discuss it. So just a quick change, now it's good. Okay, what 3 letters should I always find first? A, B, C. A, B, C. When you're given the equation, 2 of those letters are very quick to find. What's A in this case? 3. It's always the big square root of the bigger number. What's B? 1. Not because there's a 1 there, but because the square root of that number is also 1. It stays the same. And now C. Think about what that would be. C squared equals A squared minus B squared. 9 minus 1 is how much? 8.
Yeah.
So C is the square root of 8. Right. So the directions are to discuss. First thing you should always write down when you discuss it. Center. Do the center first. Because everything else is relative to the center. If you don't know the center, you don't know anything. Where's the center in that equation? It's the origin. Again, it's going to be very obvious when it's not the origin. And that's the last thing I'm going to show you. Okay, so the center is at the origin. What's the next thing I should do? Yeah?
Major axis.
The direction of the major axis. This is going to tell you which way everything is going. Left and right, or up and down. Which way is everything going here? Up and down. The bigger number is under y, so everything is going to be, think of how the y-axis goes. Up and down. So vertical. Okay, vertices. How far are the vertices from the center? Yeah, 3 units away. And then which way? In which directions?
Oh, right. Is 3 units, like from the origin.
So from the origin, go 3 units.
Right.
That would be if the major axis was horizontal.
Oh. Okay.
Up. And?
That'll be positive 3, and then you go down
And down. Yep. So up and down. So your vertices are 0. I just write them like that. If you want to write them separate, you can. 0 plus or minus 3. And lastly, how far are the foci from the center. One is the distance from the center to the minor axis. What's the distance from the center to the focus here?
Square root of 8.
Square root of 8. And the foci are going to be square root of 8 units away from the center. Which way?
Left and right.
No, left and right would be if it was horizontal.
Up and down.
Vertical. Vertical is up, down. Okay. So if I go square root of 8 units above the center, I'm at 0, comma, square root of 8. If I go square root of 8 units down, I'm 0, negative square root of 8. And those are the 4 things I'd be looking for. I might not even ask for all 4. Maybe I'd just say, tell me the vertices and the foci. Questions on that? So remember, vertical, up and down. Horizontal, left and right. All right, so one more, and then we'll look at the last thing, which is what happens when the center is not at the origin. Okay, so now you find the equation. I'm telling you where the focus is. For some reason, I'm only telling you where one of the foci are. And I'm telling you where the vertices are. What are you missing here that usually I give you? Yeah?
The center.
The center. But I would say based on that information, you know the center. Look at that information right there. You have a vertex that's up 3, and you have a vertex that's down 3. Well, the center is going to be exactly halfway between those 2 points. So where is the center? It's at the origin. So technically I didn't give you the origin, but I really did. You knew it based on that information. Okay. So now, what would A come out to? Distance from the center to the vertex. 3. Yep. B, you usually never have enough information to find B, unless they give you a sketch. Bless you. But C, you got enough information for that. What's the distance from the center to the focus? 2. Now we can find B. C squared equals A squared minus B squared. So B is going to end up being the square root of 5. Which isn't really that important unless you wanted to sketch it. What you really need to know is that B squared is 5. So let's make our equation. Whether you're going to do the type from today or tomorrow, you can always go like this. All that stuff is the same. For today, what goes between the 2 fractions? Plus. The numerator of my first fraction. It's always my x. It might have something added or subtracted to it when it shifts, but it's always going to be your x. That's always going to be your y. Now, look at my vertices. How do they line up? Vertical or horizontal? Vertical. So put the bigger number under y, out of the a and the b. So be careful, what number is going to go under the y? Well, b's the smaller number. So, not quite a though. 9. A squared. And what's going to go under the x? 5. A squared, b squared. And there's your equation. Okay. Any questions on that? Alright, so last thing. ellipse can be shifted, so the center is not at the origin. When you shift it, the center is h, comma, k. So when you see the letters h, comma, k, they are the coordinates of the center. So when you have a problem like that, h and k are very quick to find. There's the center. One of those numbers is h, the other number is k. After you have h and k, everything else is the same. You find a, b, c, just like we've been doing all along. So the equation looks a little different when you shift it. It's still equal to 1. There's still a plus sign between the two fractions. There's still an a squared. There's still a b squared. A is still bigger than b. B is still bigger than 0. Everything I'm saying is the same. C squared equals a squared minus b squared. Same. What's the difference? Now you've got this h and k. X minus h and y minus k. I never wrote them before because the center was at the origin. Well, if the center is at the origin, h and k are both 0. Minus 0, minus 0. I didn't need it. That's why I just wrote x squared and y squared. Now, why would the major axis be horizontal here? What tells you that it's horizontal? Besides the fact I wrote that. Yep. Jade?
The H is in the order.
No, it doesn't have to do with the h and k, because remember, we didn't have h and k before, and we were able to tell which way it went, horizontal and vertical.
Where the bigger number goes.
Where the bigger number goes. Okay? A is always the bigger number. Put the a under the x, it's going to go horizontal. So when I write the vertical equation, what do you think is going to be the only difference in all that stuff?
A and B are switched.
A and b are switched. Everything else is exactly the same. X minus h squared, y minus k squared, plus equals 1. All this stuff is the same, so I'm not going to copy that over again. It's just you put the bigger number under y now. That's all. And that's in your packet, not in your textbook. If you look in your packet, on page 394, it shows all these formulas. I'm also not going to write A, B, and C again. They have the same meaning. A, center to vertex. B, center to minor axis. C, center to focus. None of that changes. Now, be careful here. Like if h was -2, you can get something like x minus -2, and then it would change to a plus. So that can happen. Anyone else need to copy those two? So, last one, let's look at the equation of an ellipse, where the center is at 2, -3, the focus is 3, -3, and the vertex is 5, -3. So, you still have to find A, B, C. That doesn't change, but there's 2 extra letters now, H and K. Even though you get 2 extra letters, those are usually the quickest ones to find. So, anyone think they can tell me what H is in this case?
2.
Yes, H is 2. How about K?
-3.
Done. So H and K are done. Now, out of A, B, and C, 2 of those I have to have enough information to find. And the third one, I'll use the formula. Anyone tell me out of A, B, and C which one I can do? Yep, A and C. A is the distance from the center to the vertex. Well, if you look, all the y values are -3. So that should tell you something. That should tell you how the points line up. They all have the same y value. So if you want to know how far apart things are in this problem, just look at the x's. What's the distance between the center and the vertex?
3.
Center to vertex is 3. Center, vertex. So that's 3. center to focus is 2. No, that's not 2 either. I don't think 2 is going to come up here. What's the center to the focus? 1. Okay, so that's great. You got A and C, but the letter you really need to write the equations are A and B. So, how would I figure out B?
Put it in that formula.
Put it in the formula. Can you tell me what it would be when I plug everything in?
1 equals 9 minus b squared.
9 minus b squared. Negative 8 equals negative b squared, or 8 equals b squared. You don't really need b. B is the square root of 8. We're not sketching. Okay, you need b squared. Okay. So now, let's set up our equation. All right, one more time. Equation for an ellipse, always equal to what number? 1. Always equal to 1. It's always 2 fractions. What goes between them?
Plus.
Plus. What letter is always in the first numerator?
X squared.
It's always an x. Now you're going to have a little more with it, but it's still the x. What letter in the second numerator? It's the y. And that's all I can do without looking at some more information now. Okay. X minus h. Doesn't matter what version of the formula you're using. It's always x minus h, y minus k. So, what would I put as my first numerator? X minus what?
2.
2. Now, be careful. Second numerator is y minus k.
Y plus 3.
Y plus 3. And that's something you also have to be careful about if you wanted to go backwards, and I said, what's the center? Don't say 2, 3. The center here was not 2, 3. It was 2, negative 3. So you just got to be careful when you look at that. All right. Now, one of these denominators is going to be what letter squared?
A.
Yep, A. And what's the other denominator going to be squared? B. So one of them's a squared, one of them's b squared. We just got to make sure we put them in the right spot. Easiest way to figure it out, draw those points. I mean, I'm not saying like draw it perfect, just a quick sketch. Write 2 down 3. Write 3 down 3. Write 5 down 3. They're all down 3. Let's see. So how do those points line up?
Horizontally.
They line up horizontally. Which letter here means horizontal, x or y? X. Put the bigger number under x. So, what's going to go under x? Yep, 9. And what's going to go under y?
8.
8. And there's the equation for your ellipse. So it's not really like it's like a 50-step process, but it does take a little bit of time to get to A, B, C, H, K. But once you have that, you're pretty good. Any questions on that? So on the test, I think there's maybe 3 or 4 problems exactly like the stuff I just showed you on ellipses. Okay, so homework, again, in your packet. It's all odds. Okay, 13 to 17 odd, 21, 27 to 31 odd, and 39 to 45 odd. Yeah, I purposely left out certain problems because we didn't cover certain things. So if you ever review for the test and you just pick problems randomly to try, I would probably pick these. If you pick other ones, it might be something I didn't teach